Hi, in my previous tutorial I was showing how you can create a formula checking or formula syntax checking from a string which is containing a formula, and basically you can get if the formula is correctly formed or not. However, when you want to make formula evaluation solution, you need to split the formula itself into separate elements. So you need to have the variables, the operators, um, functions, maybe um, splitted to be able to finally uh, end up with an array, a string array typically, which is containing numbers, functions, parentheses, starting and ending, and so on. So basically, you need to work out how you can split it into these elements, because in a reverse Polish notation, you need to have all these, let's say, put into an order in which order the computer can correctly evaluate the sequence of the calculation. So I changed a little bit the code, and today I show you how you can do this in your application. So basically, if we go back to the application where I have this calculation creating a form, then of course when I build up the formula itself, then I can use variables. So these variables will be fenced with a square bracket, and then the rest of the formula will be defined as it is. So the solution works on a way that if I'm adding the variable, and here you can see in the output I'm showing that how it's split it up. So because this is the first element, of course this is just one element which is used here. But if I'm adding the next element, you can see that already here in the new calculation line, it's appearing in a separate line. This means that my string array is now, or my string itself is splitted into two separate strings. One is the variable, the second is the operator. And then I can continue to add, of course, the different things what I need, maybe like this one, and so on. So I can continue, and why I was putting here the sinus and the p value, because as you can see, the solution is taking care about splitting the numbers, the strings, I mean the function names, and also the variable names, or we can consider the p as a function as well, which basically gives back a value if we calculate with it. So as you can see that now I have a sequence of items. So if I'm going from left to the right, I get everything what is needed, and then based on this split, I can start to create the reverse Polish notation. So let's see how the code is defined. So instead of taking this is formula syntax valid, which I was showing in the previous tutorial, I was defining a split string procedure, and I also defined some variables here. So at first I have the splitted formula variable, and of course later on I will have this RPN formula, which will be the generated reverse Polish notation list of strings, which will also contain which element will be there. I mean, the string will be the element itself, like this variable here, or the plus sign, or the number. And also there will be a type behind, which will tell to the calculator that what it needs to look for. So if it is for example a function, or if it will be the constant value with a name, then these will be of course selected from based on this type, and then the formula can be evaluated correctly. So let's check the split string um, procedure itself, and this is here. So what you need to consider when you are building such an application is that what is your goal, so what you want to achieve. And here what I wanted to achieve, of course, that I needed to think through how my string is built up. So what is it consist of? And that's why I had to say that I needed to define basically if the position where I'm in the string is a number, or it's a variable, or it's a function name, or it's an operator. These need to be handled, and basically the characters need to be collected into one element. So when I'm going through the string, I need to define where to split exactly the string to different elements. So the first one is, of course, that I need to have kind of separator elements, and this is what I defined here under the SCH array, and basically this is telling that when these characters are inside the string, this means that either I have an operator in front, or a number in front, or after that. So with these characters I need to split the whole string, but this is not enough, because if I'm going into a number, or I'm going into a variable, within the variable I might have a similar character. Of course, if I'm saying that you cannot use a plus sign in a variable, and so on. So if you limit what can be inside a variable name, then you can also define how you want to do this split. So in my case, this was relatively simple. So I had this separator character, or invariable character, which is starting a variable with the square bracket, the starting square bracket. That is used basically for defining that with this character I'm going into a variable itself, and I need to handle this until the other side of the characters are coming in, or I will have any other separator character inside. I mean, inside the string itself of the complete function. So this is one thing. This is, of course, the second thing is the separator. So where I might have a new element coming, and this is of course required when you are going from one element to another, or you have a calculation barrier, let's say, between the elements. The third one is the number, or the variable or function name. So basically, when I want to split the things, then I can have a variable name or a function name, which I need to again follow until I get another separator character. And of course I need to use these operators as well every time, so I cannot just simply say that 5 sinus means that 5 times sinus. I need to have 5 times sinus in the string itself, otherwise the system would not be able to distinguish what is the number, what is the variable, what is the function, or it would be more difficult. So these are the three items, and I have basically two two different positions or two different considerations here. So because I will go through the string itself step by step, and I go through by characters. I need to know if I reach the point, or I'm inside a point where I need to evaluate a number, or it's a function. So for this I define this in-digit and an in-variable Boolean values. So these are showing for the cycle that now I'm still evaluating or still putting together a number into a string, or I'm still putting together a variable into a string element. And then if these are still, let's say, within, I need to wait for the next separator character, which can be a function name, or a bracket, or it can be an operator itself. So the function itself is relatively simple, so I try to make it a bit bigger to see more. So this is the complete splitting function here. So what it's doing is, of course, at first I'm basically cleaning out everything to start with. So the split formula value, if I might have another calculation done already, or splitting was done, then I don't want to continue and adding more elements, but I need to basically nil it out and clean it out completely. And I use a substring. This substring is basically collecting the characters for each element. So until I'm within an element, I'm collecting the string or putting together a string into this substring, and when I need to switch to the next element, then I clean it out again, and I put into the splitted formula variable or array the element which was put together already. So the cycle is starting, of course, with an I s1. You might be already knowing that the Pascal string is starting the string with the first character at the first position. The zero position is typically handling the length of the string itself, so you should not use the zero character as a character of the string. Of course, at first the cycle will last until the last character we reach. So the last character is, of course, the length of the expression what we got into this procedure. So as you can see here, we have in the procedure definition or procedure line the expression itself which we got into the procedure. So then I need to check if I'm inside a variable, and if I'm not inside a variable, then I can check if I'm inside a number, or I'm starting a variable itself. And if I'm in a digit, then it goes to true, and if I'm in a variable, then the variable goes into true. And then this character what we have here, we can start to put into the string, into the substring. So because it starts with a 0 or nothing, then it will add the character to it. The next step after we added the character to the substring is that we need to check if we are at the end of the string or not. This we can check on a way that actually we are checking if the next character is still within the string, or it's exceeding the length of the string. So checking the I+1 means that we are checking the next character, and the next character we will use here in this stage to decide if we still need to add something to the substring, or we can complete or we can copy the substring into the element. And if we added it into the element, then of course we need to start a new substring. So that's the task. And here it's very simple. So basically if we reach the end of the string, then we come here at the end of the this if statement, and then we basically can complete the string by adding it into the formula, and then we can close it, because the next step will mean that we are basically finishing this cycle here. Inside, so if we did not reach the end of the string, then we need to check if we are basically collecting the characters into a number, or we are collecting the characters into a variable, or actually we treat the digits not just as digits but also function names. So basically we are distinguish between variable or digit, or other functions, or constant like p and other predefined constant values by name. So if we are in within this, so we are collecting a function name or a number, then we simply just need to check if the next character in the string is a separator character or not. So if we are getting an operator, or we are getting a bracket, if we are at a separator, then we simply need to add the substring to the splitted formula, and then we need to clean out everything. So the substring that we are basically leaving the in digit status or in variable status. So if we are not in a number or in a function name, then we need to still check the next character, if the next character is a separator character, or if the next character is a number or a letter, but only if we are not in a variable, because if we are not in a variable, then we need to wait until the let's say the closing character is reached. So once we went through of these things, then of course our string is separated for those elements what we need to handle later on individually in our reverse Polish notation. So once again, if we go back to the application and check again the split, so as you can see we have this split, and if we might continue to add additional elements, then we could do it on a way that we did before. So as you can see, whenever something is added, all split it into this separate values, or let's say we can call them tokens. So once these tokens are generated, the next step will be to put them into the right order. So this is what I wanted to let's say show today, how you can make such a kind of split, or how you need to consider all these steps, what you need to do to get where you want to go. The first thing, of course, like in every programming task, is that you define clearly what is the goal, what you want to do, and basically you need to evaluate what might be the status of your elements, or what you will have an input, and what you want to have as an output. And then basically the task is simply to follow the logic, and check every time what you let's say planned is really doing what you want it to do. So I hope you like this tutorial, and if you liked it, then don't forget to subscribe. And with this, I wish you happy coding, and see you next time with the reverse Polish notation solution. See you next time, and goodbye.